Hello Science Lions! Hello! My name is Lara and this is a LEGO Storytime show where I tell you all about a thing that I've learned this week and then we do a LEGO story at the end. Are you ready for the LEGO story glimpse? Yep. There we go. We've never done this before. We've just done, if you're watching live, we've just done a series of 5 lessons on the polar regions and we've just done a whole lesson about the Aurora, the Northern Lights. But there was just a bit more to say and more activities to do, so I thought we'll do a LEGO story show as well. And we're also going to do an activity that we've never done before. It's almost a craft. We're going to build a spectroscope which lets you split like white light, say, into all the colours of the rainbow. I've never tried to do it before because it's always seemed a bit faffy, but actually I've made this one, which is really simple. Thank you, Exploratorium website again. And it does work. So you're going to make this with me, and then we'll use it towards the end of the show, before LEGO Story Show. Okay, so the first thing you need to do is get a piece of card. Cereal box is perfect thickness for this. And like you can see here, you need to roll it into a tube, but please don't tape it yet. You need to just have it as a tube shape that it can be sellotaped, but don't actually fashion it into a tube yet. So I will do that with you. So I thought we should probably recap because maybe some people haven't seen the Northern Lights lesson that I just did. I'll recap what we just did in that lesson quickly, and then we'll focus on like a different bit of the Northern Lights for the show, okay? While you're cutting out your cardboard and rolling into a tube like about the sort of same width as the same diameter as a toilet roll tube, but it'd be better if it would be a bit longer. So if you've got a piece of card that's kind of A4, roll it long ways. It's quite hard to roll cardboard, isn't it? So it doesn't matter if it's a bit angular, but you just need to have it as a tube. Like about 2.5 toilet rolls long, I reckon, is perfect. So what we've just been learning about is, it's in the north it's called the Aurora Borealis. In the south it's called the Aurora Australis. That's how you pronounce it. It looks like this. These beautiful sheets of green and red light kind of moving around the sky at the North and the South Pole. Here's another picture, thank you NASA, taken by the astronauts. So in the lesson we were looking at how an atom is, we're just going to say it's a proton with an electron whizzing around the outside, right? The proton's positive, the electron is negative, and this is what an atom is. In the sun, the atoms have got so much energy that they're basically split up into just loose protons and loose electrons. And when electrons and protons are loosey-goosey, we say that that is a plasma, all right? So you've got this kind of loose soup of protons and electrons in the sun. And in the lesson, we said that these protons and electrons are constantly streaming off the sun. This sun comes off the plasma, and we call that the solar wind, okay? So the solar wind, obviously, because Earth is quite near the sun, the solar wind comes towards Earth as well. So protons and electrons, called the solar wind, streaming towards Earth, yeah? And, this was a cool fact. We learned about how comets, when they get near the sun, they have 2 tails because the solar wind actually pushes the particles of the comet off in the same direction the solar wind is going. That's just like a little FYI. We also learned that Earth is a massive magnet, and confusingly, Earth is a magnet, but the South Pole, the south end of the magnet, is at the North Pole. So that's like the geographic North Pole, but it's actually the south end of Earth's magnet, and the geographic South Pole, where the penguins are, that's the north end of Earth's magnet. But Earth is a magnet, and because it's a magnet, it is surrounded by these magnetic field lines. I'm going fast because I'm assuming that you've seen the lesson, but if you haven't, it doesn't matter because now you know. Earth is surrounded by magnetic field lines, and charged particles, like the solar wind, they can feel magnetic fields. So here's a beautiful picture that we looked at finally to show what happens. You've got Earth here, this tiny little ball in the middle, these enormous magnetic field lines showing Earth's magnetic field. And we said that the solar wind, the particles of protons and electrons, and some other stuff, but it doesn't matter, whack into the Earth's magnetic field here, this bit called the bow shock, and then curl around and kind of bend Earth's magnetic field into this beautiful teardrop shape, which is called the magnetic... I just gesticulated wildly with my hands and knocked my camera phone over. So this whole teardrop-shaped magnetic field situation here is called the magnetosphere, and it's great because it stops the solar wind getting to Earth. But we said, actually, the solar wind does a little bit get to Earth, but it's just channeled because of Earth's magnetic field lines, it's channeled towards the poles. Whew. Right. So, we have Earth's North Pole and South Pole with particles, electrons and protons from the sun, the solar wind, heading down towards Earth's atmosphere, like towards the air above the North and South Pole. Have you got your cardboard tube? So, we focused more on the magnetic side of the Northern Lights when we were doing our lesson. So I want to focus more on the atoms of Earth's atmosphere, like how you get those lovely green and reddy lights. So what I'd like to do, if you've got your tube, you need to, this is why we shouldn't really roll it yet, you need to flatten it. I mean, actually, just fold the card in half, if you like, really. Fold the card in half long ways, make sure it's straight. We need to cut a diagonal slit, and that's what we're going to stick our CD in. So you look through one end of the tube and you see the CD, and hopefully a rainbow should appear on the CD. So I went a bit wrong yesterday. My practice one was great, and then when I did it live on Facebook, I made my angle too, what is that, too shallow or too steep. I cut too much diagonally, and then I decided it would be better to cut a little bit less diagonally. So let's try, actually it's about 45 degrees, isn't it? My proper one that works. So let's do 45 degrees again, roughly. Here we go. So like that I'm gonna do. So start in the middle and go off to one side and put in quite a generous cut, because we need to be able to really stick the CD in there. And still don't sellotape it up, please, because once you've done that quite generous cut, you need to do something else as well. Well, actually you can roll it up after this. So fold it flat along the long edges, cut your diagonal cut, and then once you finish that, actually you can just roll it into a tube after that. So I said that the solar wind, the particles, the protons and electrons, they come off the sun. Let's go into a little more detail about where they actually come from, because the sun has a lot of different layers. We quite often talk about the surface of the sun. There isn't really a surface of the sun in the same way that we think of a surface of the Earth, because the sun is like, it is kind of a gas. So I think even the most densest, most solid bit of the sun is still only about as solid as the air around you right now. So you can't like land on the sun. But the very outside of the sun is called the corona. Here is a picture. Again, thank you, NASA. So the very outside of the sun is called the corona here. That's where the solar wind comes from. And if you enjoyed the fact that I sort of kept saying that the solar wind was a little bit like the sun farting, you'll really enjoy the fact that the exact bit that the solar wind comes from in the sun is the coronal holes. The coronal holes. The corona's got holes in it, and that's where the wind gets farted out of. I think the coronal holes here are actually the dark areas. So when we take images of the sun, we usually don't use actual light, visible light. You usually use X-rays, and the coronal holes look dark on X-rays. You should obviously never look at the sun with your eyes, but you can't see the coronal holes anyway, they're invisible. But yeah, what happens is the sun is a magnet, so the sun has a magnetic field as well, and in these coronal holes the solar wind streams out, and it sort of brings a bit of the sun's magnetic field with it, which can cause huge problems for us. That's what LEGO Story Show is about. But here is an actual photo from NASA of what we call this streamer of solar wind coming out of a coronal hole. Can't stop saying coronal hole. Look at that. So I thought, well, this means nothing to you, really, because you can't tell how big it is. This is a streamer, I think, a couple of streamers of solar wind. This white dot here is quite useful for scale. Can you guess what that white dot is? What's the white dot on that picture? That's for scale. So the sun would be over here on the left. You've got these two visible streams of light coming off the sun, which I'm pretty sure, according to the NASA website I got this from, is the solar wind. It's come from a coronal hole. What is that white dot? It's Mercury. I know. Scales, people. You can't imagine it, can you? So this is a planet here, and this is this stuff coming off the sun. It's big. Right, let's carry on with our spectroscopes. I haven't even told you what it's for yet. So you can roll it up once you've cut that diagonal slit into a toilet roll shape. There we go. And then once you've sellotaped it, you need to fold it again because we need to cut a little rectangle at the bottom to let the light in. So I keep saying to you, loads of lessons I always say, white light is made of all the colours of the rainbow. That's often not quite true, actually. So we were learning in the lesson about how different atoms, carbon, oxygen, nitrogen, whatever, different atoms, they all give off a slightly different combination of light when they get excited. So I'll just, while I'm sellotaping this, I'll just tell you. We did do this in the lesson, so I don't want to go into it too much, but we looked at how, let's just say that, let's just use one proton and one electron. I know that that's not what oxygen and nitrogen are like, but there are atoms in Earth's atmosphere, right? The air that we breathe in is made of mainly nitrogen and oxygen. And they are made of atoms. And when atoms get excited, like for example, when the solar wind smashes into them, when they get excited, the electrons jump up and then they go down again. And when they jump up and down, they do this kind of little hiccup and they give off light. So oxygen gives off sort of green light. Again, we'll go into more detail in a sec, but sort of greeny, reddy light. And nitrogen gives off sort of green light as well. But actually all different atoms give off different combinations of light. So like, if you, obviously, yeah, don't look at the sun with your eyes, but the sun is giving off slightly different colours because it's obviously made of slightly different things. Like a neon light would give off slightly different colours because neon is an atom which gives off different colours. So what we're going to do is we're hopefully going to use this to separate out the different lights around us into what colours they're made of. So when you've got your slit and you've rolled it into a tube, you need to cut a hole, kind of, if you see where the diagonal line has started, you need to cut a hole at the bottom underneath that diagonal line, but only quite a small hole because that's going to let the light in, and then the CD which goes in the slit is going to split it all up, right? So here's mine. I've got my CD like that, and then my hole at the bottom there. So the light goes in there, hits that CD, and hopefully when we put our eye through here, you'll see a rainbow. Okay, so let's give it a go. Is it going to be the same as that one? Maybe my hole, actually, my hole's quite far back, isn't it? It's not underneath the top of the slit, it's more underneath the bottom of the slit. Maybe that's where I went wrong on Facebook yesterday. Cut your hole underneath the bottom where the CD will be. So, for example, if I've squished mine here, yesterday I put it there, I think I'm going to move it back a bit. So just cut a little rectangle underneath the bottom of your slit. I hope this works. I think this is the safest way to do it. I didn't want you all like trying to stab holes in tubes with scissors, but if you just cut a little rectangle out like that, then obviously when the rectangle comes out, you'll have a hole. See, I really said the word hole a lot in this show. There we go, like that. See? Is that okay? So squish your tube, cut a diagonal slit, and then at the bottom of the slit, obviously make sure that the two holes don't meet or the tube will come apart. You've got a little hole like that. Is that all right? Okay, while you're doing that, I'll chat to you a little bit more about some more Northern Lights stuff. So we've talked about why this light is given off. We'll talk more about light when we finish this. What the Vikings used to think about the Northern Lights, I found absolutely fascinating. So I have to admit, people keep asking for a Lego story show about Viking myths and legends, and I totally should do it because I don't actually really know that much about them. I knew the word Valhalla and I knew the word Asgard because films and stuff, but I didn't actually know what the difference was between Valhalla and Asgard. Do you know what Valhalla and Asgard are? Have you heard of those things? So what it is, with apologies to Viking experts, Odin is the god. In the Viking times, the Vikings believed that there were loads of different gods, and Odin was like the head of the gods, and Asgard was where all the important gods lived, all right? So Asgard is like a big place where all the gods live. Valhalla is just one hall inside Asgard where mere humans like us are allowed to go. So when there were battles in Viking times, and there were many, the Vikings used to believe that these big sort of almost like angel type creatures called the Valkyries, who worked for the gods, the Valkyries used to come down from Asgard pick up the best warriors who died on the battlefield and take them to this big hall called Valhalla, which is in Asgard, all right? And the Vikings used to think that the Northern Lights were the lights shining off the Valkyries' armour as they came down to pick up the finest soldiers and take them up to Valhalla. Isn't that amazing? So lovely. I don't know whether all Vikings believed this, like absolutely, or whether it was just a story, or whether some Vikings were like, oh, well, we don't really know what it is. But anyway, it's just a beautiful idea. And in Valhalla, that's where all the very cool, awesome warrior Vikings would wait for Ragnarok, which is the end of the world. Like massive battles, end of the world stuff. Okay, whew, have you done that hole? Here's a cave painting from, I think, 30,000 years ago, which is, we think, possibly the first record by humans of the first record. I mean, it's not like squirrels were drawing them. The first record of the Northern Lights. No offence, squirrels, I mean, maybe. Look at that, a cave painting, and we think this might be the Aurora, the Northern Lights. What do you reckon? It's quite cool, isn't it? I mean, I think that's quite, I think it's highly likely. Okay, how are you doing? Have you got a tube with a diagonal slit in it and a hole at the bottom? If you've got that, to be honest, it's pretty much ready. If you're feeling fancy, you could get another piece of cardboard and cover up the end of your tube to make it dark, but you can just do that with your hand. That's all I'm doing. So here's the moment of truth. You've got to stick your CD into the diagonal slit and then just look through the one end of the tube at the CD. Cover up the far end, look through the front end and see if it's, oh yeah, come on. Ah, it's even better than the first one that I made in practice. Oh, that's great. Splendid. If you're not seeing a rainbow very clearly, maybe you're letting too much light in and you want to get, you know, got like a little gap there, which is letting in quite a bit of light actually. I don't really know how to, oh, I suppose if you're happy to keep the CD in this position, I could get a bit of sellotape actually and thread it through that hole. So kind of, yeah, I'm going to do that. Here we go. And then we'll point this at different things and see what we can see. Okay, that. So I'm going to put, I haven't done this before, but I think this will help. I'm going to sort of push my tube together at the top so that not as much light is coming in, and then just sellotape it shut, she says. Oh yeah, I'm just going to do that. It'll be so easy. It's not really working. I need to, oh, I'll get a pair of scissors and stick it in so that I can push down. Just trying to get that little hole sealed. Yeah, I think that's better. Okay. Oh, just while you're finishing that off then, I thought another question you might ask is, are there northern lights, or is the Aurora on other planets? And the answer is yes, the Aurora is definitely on other planets. It turns out all you need for an Aurora is a magnetic field and an atmosphere. So the solar wind gets channeled down your magnetic field into your atmosphere, collides with particles of, say, oxygen and nitrogen or whatever, gets them all excited, so they release light. Bob's your uncle. So here's a photo. I mean, it's not just one photo, it's lots of different photos that NASA take and then layer them over each other. But this is Jupiter's Aurora. Isn't that splendid? Look at that. Cool. Fabulous. So yeah, they do have Aurora on other planets. Oh yeah, and finally, how it gets its name. Aurora was the Greek goddess of the sun rising, of dawn. It's not quite borealis, but like boreal, I think, was the Greek god of the north wind, and and the other one was the Greek god of the south wind. I'm sure I had it written here somewhere. No. Come on. Oh, here we go. Auster or Auster was in Greek mythology the god of the north, of the south wind. So Galileo Galilei actually named, I think, the northern lights, and I think Captain James Cook, when he was exploring and crushing people's souls down in the south, named the southern lights. Right. let's talk about these lights, okay? So I've been saying how we think of white light as being made of all the colours of the rainbow. Yeah, you maybe know this. So red, yellow, green, blue, orange, indigo, violet. If you mix them all together, you get white light. But it's a little bit more complicated than that, because like I say, different atoms give off different colours. So for example, the sun, never look at the sun, but the sun, it doesn't give off every single colour of the rainbow. It gives off the colours that the atoms, the elements that are in it, give off. So if you point your spectroscope that you've just made at an electric light bulb, you'll see pretty much a whole rainbow. Not the entire rainbow, because an electric bulb isn't giving off every colour. Here, I'm just going to put you into my spectroscope. There we go. So come here. This is the one that I've just made. I'm going to turn it around so that the hole is facing my electric light. Because the sun is obviously shining in my house as well, but I just want the electric light so far. Why does that just look... Oh, there we go, right. So I've put that right underneath my electric light. And you can see there, so CDs just happen to be brilliantly made so that they reflect light and split it up into all its different colours. So you can see that my electric light in my house is pretty much giving off what we call the whole spectrum, isn't it? The whole spectrum of colours. Red, orange, yellow, green, blue, indigo, and... Oh yeah, look, there's violet at the end. If I go over to my window now... obviously, yeah, don't look at the sun, but you might see a slightly different spectrum, because that is, I mean, it's snowing actually, but those are the colours that the sun gives off. There we go. So not very dissimilar, but slightly different. And if we go over to my computer screen now, I've got something set up which should help. Oh yeah, so if you look at the colours that just one particular atom gives off, it's called the emission spectrum. So like the colours that particular atom emits. So this is the emission spectrum of oxygen. Which is why I sort of said that oxygen, when it gets excited, it gives off red and it gives off green. So it doesn't give off every colour of the rainbow. If it was all the colours of the rainbow, then that would be this whole strip. But you can see it just gives off red, a little bit of orange, a little bit of green, and a little bit of purple at the end as well. So this is basically the light that oxygen gives off when it gets excited. So what I've done is I've just put lots of different colours on my screen. So I don't know if you know this, that we've done a whole lesson about like how our eyes work, but computer screens, they're just loads and loads of teeny tiny little lights, and different colours of lights light on to display things on the screen. But they're actually only made of blue and green and red lights. So if you're looking at yellow on a computer screen, it's not a yellow light that's on, it's a green light and a red light that are switched on, but they're really close to each other. And it just so happens that when red and green light get mixed up together in your brain sees yellow. It's amazing. So I've got different colours on my screen, and I thought we can have a look through our spectroscopes and see what the different colours look like when they're broken up. So our spectroscope is going to split all the colours into the real colours that they are. Right, so I've got my hole pointing at the screen. Here we go. Right, so it's a bit confusing. You can see the hole where the red screen is there, but you can also see the red on the CD. So here we go. Red light is, at the moment on my computer screen, only the red lights are lit up. So unsurprisingly, we can only see red light on my spectroscope here. So if I change to green, that's interesting, isn't it? So you can see that there is a little bit of blue. Obviously there will be some sun shining as well on my screen. I've tried to stop that happening. So there's a little bit of blue in there, isn't there? Let's move on. This is blue, so you can see that my computer's really just giving off blue light. But this is interesting here. So this is magenta. And can you see there's actually, try and wiggle that around a bit. Yeah, so magenta is actually made out of blue and red light. Look, isn't that great? So it's actually on my computer screen, it's tiny little red lights and tiny little blue lights that are switched on, but they're right next to each other to make magenta. But if you look at our spectroscope here, you can see the blue lights and the red lights have got split up. So this is yellow. There you go. What did I say? So yellow on the screen is actually green lights and red lights stuck together. Let's try another one. So this is, it's weird, you would think that it's blue. This colour is actually cyan, and cyan is made by mixing the green and the dark blue together, look. And that's white. So as you can see, although it looks white to our eyes, we say, oh, white light's made of all the colours of the rainbow, but that white light is only made of 3 different colours, red and green and blue, all switched on together. Isn't that great? And then obviously if the screen is black, then no light at all. So there you go. You can have some fun with that today. If you've got one of those like strip lights, you know, that you sort of flick them and they take ages to kind of spark on. You get them in scary movies, and my parents' ancient kitchen. They're really good. They give off a completely different spectrum as well. But yeah, if you've got any neon lights, then you will see the emission spectrum of neon if you point it at that. Wow, it's good, isn't it? Right, I think that's everything. All the detail that I had to go into about the Northern Lights. Yes, we can do story time now. Let's do it. Move that out of the way. Shuffle up here. Don't spill my coffee. Coffee, you can go there. That can go there. And you can go there. Okay. 165 years. Does that sound like a long time to you? It wouldn't be that long to a 200-year-old Greenland shark, for example. Or if you've ever found an ammonite fossil on a beach, an ammonite fossil would be at least 66 million years old. So to an ammonite, 165 years would be like, I don't know, the length of time they have to wait before their favourite YouTube video comes on. Hardly any time at all. The events of today's story take place 165 years ago. How long ago you think that sounds will decide how scared you will be. So, September the 1st, 1859, amateur astronomer Richard Carrington was sat in Redhill, a lovely little town in Surrey, studying marks on the sun called sunspots. Never look at the sun. He was actually sketching them when he saw 2 patches of intensely bright and white light. Richard didn't know it, but he had just seen the sun give off the same amount of energy as billions of atomic bombs. What happened next is now called the Carrington event. So, as we have learned, magnets have magnetic fields around them. That's how you feel them push and pull, even though they're not touching each other. Earth is a magnet, and the sun is a magnet too. Carrington saw something called a coronal mass ejection, which is where a ball of plasma, many times bigger than Earth, bursts off the sun and carries some of the sun's magnetic field lines with it. Less than 18 hours later, this coronal mass ejection debris hit Earth. Now, usually, Earth's magnetic field acts like a massive shield and protects us, but if the Earth's magnetic field lines and the sun's magnetic field lines, as part of the solar wind, are going in opposite directions, something called magnetic reconnection occurs. The field lines join and create a breach in Earth's shield, allowing particles from the sun to pour towards the planet. It's called a geomagnetic storm, and Carrington's was the largest one ever recorded. In a Victorian telegraph office, an operator reported streams of fire pouring out of the circuits. Sparks leapt from equipment. Some operators got electric shocks. Workers in Boston found that their lines were down, but luckily the atmosphere was so electrified that they could actually still send messages. The Northern Lights, as we call them, were seen as far south as Cuba, which is here, right below Florida. The sky in America was described as being the colour of blood. Birds began to sing. Some people who thought nearby cities were on fire. Some people who didn't have clocks just assumed that it was morning time and got up and started work. It was Carrington who realised that these weird events must be related to the huge flash that he'd seen from the sun. Now, The Carrington event was dramatic, but it occurred at a time when people use like actual paper money to pay for things and paper maps to get around. And people lived fairly near each other as well. If it happened today, it would affect satellites. You know, the things that aeroplanes and ships and cars use to find their way around. The things that make mobile phones work. You know how you pay for things just by like tapping a card against a box because magic? It's a satellite allowing you to do that. Power might be affected too. National Geographic quotes one expert comfortingly as saying, imagine large cities without power for a week, a month, or a year. There are solutions. Scientists are getting very good at forecasting the sun's behaviour, which gives us maybe about 20 hours notice, meaning that we can turn vulnerable equipment off if the sun suddenly like spews out some solar wind. The last one, not the last one, but the sun has a predictable cycle. It peaks in activity about every 11 years. One of these things happened in October 2003, and we did see some power outages and the Northern Lights hover over Texas. So how good's your maths? There was a solar storm in 2003, and the sun peaks every 11 years. So by the scientists' latest calculations, the next geomagnetic storm period is due to hit between January and October 2004. If you're watching this on catch up, that's now. That's right now. So get outside. Turn your lights off so the sky's nice and dark, and see if in the middle of 2024 you can catch some fantastic northern light action. Also, maybe get some money out and stock up on dried goods. I'm kidding. Severe solar storms only happen every few hundreds of years, and that's ages. Right? The end. I like that bit. So any excuse to use fire in Lego Storytime always pleases me immensely. Right, oh my goodness. So that was the very end of our series, our course that we've done on the polar regions. But it's also actually the last thing that I'm going to do before half term. If you're watching live, then next week I'm taking a break because it's half term in York and I live in York and I have to parent my children. And then after half term, I'm not being rude, I'm going to my Facebook page because some of you might have come to my Facebook page to leave a comment on my post, which is at the top, to say hello to me so that I know that you're here. So if you're on Facebook, go to my Facebook page now and I will be able to chat to you. So next week is a holiday, and the week after that, we're gonna learn about Shakespeare for 5 weeks, which I've never done before. My business is theory of science. I am a trained physics teacher, but I do actually have a first-class drama degree, and loads of people have asked if I'll teach English. I'm super excited to do that. So for 5 weeks, we're gonna do all ages Shakespeare lessons instead. And the first Lego Storytime back is gonna be about the Globe Theatre, a big fire that happened at sort of famously Shakespeare's theatre. So yeah, I'm really excited about that. It'll still be quite sciencey. We're going to study Macbeth and Midsummer Night's Dream, and the first lesson's just going to be kind of overall like Shakespeare, who was he, why should we learn about him? So there's going to be quite a lot of science and magic involved as well, if you do like the science. Casper says, you've got an echoey. Oh no! Oh, no way! It's my first time live, except for the lesson today before this. I love your lessons, and my Western cereal box said loved by kids, approved by parents. That's my lessons in a nutshell. Ah, that's nice. Ah, brilliant. Hello, Edward and Annabelle and Evelyn and Rose. Having a science morning. No way, you watched the Unicorn Lego Storytime to fill the gap between my lessons. What? There was no gap between my lessons. What are you talking about? That's incredible. That is a hard science day. Hello, Ryder and Juwaria. Hello, good to see you. It's Casper again. You have no idea how much the topic confused me this morning when I thought we'd already done this one. Yeah, I know that is sorry, that was very confusing. Hello, Elodie and Izzy. Hello. Hello, Iris. I didn't see you there. Violet, it's snowing where I am as well. Can we do a Lego Storytime on dolphins versus whales? Yeah, that's a good idea. Dolphins versus whales. Yeah, that is a good idea. What is the difference? We could look at killer whales, which are actually dolphins. Biology, I don't know. Clear, you couldn't find the CD. Yeah, it's fair enough. They are a bit oldie-timey now, aren't they? Ava and Will are here. Hello. Oh, Logan and Deacon are here. Hello. Your favourite listener of the week. It's nice. Imogen and Ophelia. Happy Science Day. Sebastian and Humphrey. No, how are you still here when your mum's in hospital having broken both legs in a bunk bed related activity. You listen to the Greeking Out podcast, which is really good, and they sometimes do Norse myths. Oh, that's good. I only listen to the Silly History Boys podcast. That's the only podcast in my life. But I'm going to look at Greeking Out, because actually I do really enjoy having the history podcast on when I'm washing up. Oh, hiya, Alice. How are you doing? Hey, Ethan and Tammy. Hello. Oh, Eva. Hello. Good to see you. Not see you, that'd be creepy. You know what I mean. Hello, Sophia. Can't watch your live video now, but I'm looking forward to watching it later with my little brother. Hello. Hello, Sophia's little brother, who may be in the background. Hello, Sophia. Edmund's back. He says that the element rubidium was named because of the colour that it makes in the spectroscope, i.e. ruby. Oh, that's nice. Oh, brilliant fact. I didn't know that. If you ever get hold of any rubidium, children, burn it and look at it through the thing that we just made. Cool. Hello, Tiger and Birds. Hey, hello, Suki and Oswin, Eunice and Salah and me. Say hello. The magnetic field lines around Earth look a bit like an onion. Oh, Alice, interesting. Someone said spider this morning. You can all decide yourselves. Right, I'm just going to click refresh in case someone didn't know that these comments were here and now did and is now coming. Can you do a Lego story on that fish? All right, I'll put that fish with the long name. The fish with the super long name. Maybe we could do a lesson on that train station in Wales as well. Maybe we could do a Lego story show just about things that have really long names. Ooh. Hey, Roz and Genevieve. Oh, hello. That's very nice. Good to see you. Oh, just shown. So we have an app on Bonobo. A Lego story show on bonobos. Hello, Noah, as well. Yeah, I'm going to write down bonobos. Someone's asked for monkeys versus chimps, which I think is a very good idea. Noah's here. Splendid. Oh, Kai! You saw the Northern Lights in Iceland in September. Oh, I'm so jealous. Hello, Ethan. Hello, Fausta and Alma, who I've met in the real life. The spectroscope was spectacular. Our salutations, Lucian, son of Kerry Vert. I trust that your people are well, and I did not offend you with my haphazard, quickly Googled description of what happens when your people go to Valhalla. All right, Dylan and Truro, looking forward to the Shakespeare. Oh, you're going to Stratford in April. You should do a new Facebook thing called Theatre of English. I know, do you think I need to set up a whole new Facebook account called Science of Theatre? I don't know, it'd be embarrassing if it didn't get very many likes. Right, I'm going to go. I better do my ads, because if you happen to have sat through that whole thing and you're new, then you might be wondering how I do this for a living. This is actually my job. It's so good. So how it works is, most people who are watching actually, there's no pressure. Like, the whole idea is that if you can't afford it, then you can still have science lessons just like everyone else can. But everything I do is free. Printouts for the lessons and the Lego Storytime show. And then if people sign up to support me with £5 a month, I send them Theatre of Science magazine and just all my gratitude. Basically, people chip in £5 a month towards my wages. But as a thank you, I send them Theatre of Science magazine. It's incredibly sporadic. It just comes out when I've finished it. The latest one is just ridiculously late. But if you sign up now, I will send you a welcome pack to tide you over. So if you sign up with £5 a month, I'll send you this magazine, which is on sleep. If you send me £6 a month, I'll send you an extra magazine, which is about rainforests as well. And you get some rainbow glasses in your welcome pack, which is usually really exciting, but we've basically just made something which allows you to see rainbows. You really don't need these anymore. I'll put them in anyway. You can give them to a friend. And I'll send you a description of how they work, which will be interesting, being as you've just made a spectroscope. Yeah, and the sleep issue comes with a little bag of lavender and a piece of fabric so that you can sew a sleep squish, which will help you sleep at night. And all my comics, all my magazines have got comics in them that my husband illustrates for me, and articles about the subject. This one's got an origami koala in it. Oh yeah, there it is. So you can make this origami koala, which is kind of a bookmark. Obviously, when I made that, I didn't have the magazine because I had to take a picture. Yeah, so anyway, yours will look better than that because yours will be all shiny. Yeah, right. So thank you very much. If you have ever received Theatre of Science magazine, you are one of the people responsible for this being my job, and it's totally, obviously, absolutely the best job ever. All right, some of you are still here, so I'll just refresh my Facebook page one more time to see if I've had any more comments, and then I'm gonna go and have a week off / a week of planning a load of Shakespeare lessons and writing a science magazine. But you know, a change is as good as a rest. I really do love my job. Okay. Very excited for the next set of lessons, are you, Violet? That's good. I thought, oh, they'll all be like, oh no, we wanted you to do science, why are you doing English? But actually, loads of people are really excited about it. And even the people who say that they hate Shakespeare are still saying that they're going to come. So that's good, that I get a few minutes to try and persuade them that Shakespeare is awesome. Oh, here we go. Edward and Annabelle and Evelyn and Rose are here again. Oh no, wait, I knew that already, but now someone has commented. Oh, you did the same thing. What? Wow, you guys. Oh, what's this? A video. Someone sent me a video. Is that a magnet? Oh, wow. It's like a video of, have you just made that? An actual working magnet on a tablet. That is really cool. Well, not working, but like it actually moves. It's animated. Wow. Have you literally just done that while you were watching this lesson? That's amazing. Oh, you're going to Iceland next month. Oh, I really hope you see the Northern Lights. I really hope you do. It really scares me because like, it's quite expensive to get there. It's got to be one of the most expensive places to get to from Britain, sort of, which is nearby. And I'm like, it would be just my luck to spend all that money to go and see the Northern Lights and then not see them, because it's not guaranteed, is it? Like, you can't see them through clouds. But yeah, anyway, yeah, best of luck. I mean, I'm sure it's a really beautiful place, even if you don't see them, but I really hope you do. Ryder loves that fish. Do you? All right, Ryder, you've been watching for ages. We have to get you a Lego story show on that fish. I will make it happen. Can you do a Lego story time about pirates? Yeah, that's come up a bit. I did write a supporter magazine about pirates, and I generally don't like to repeat information because I want my supporters to have something that you don't get unless you pay me. Hello, Taylor. But it is probably time for us to do pirates as well. Maybe I could reprint the pirate magazine, but then I'd just be sending you information that I just told you about, I don't know. Also, Ross and Genevieve feeding back that a Kaiser Chiefs CD works better than Led Zeppelin. Who would have thunk it? That Kaiser Chiefs better than Led Zeppelin, at least in some ways. Bees versus wasps, yeah, that is on the list. That is on the list. Okay, right, I'm gonna go and start writing that magazine, which is on acids and will include more free little things for you to do experiments around your house. Thank you so much for coming, you lot. You know that it is hugely appreciated. I will see you all after half term.